Continuing here with the subject of caching with ICE, now we're going to have a look at another method of caching. It's not as flexible and doesn't give you as much control as the previous method that we saw in the video before this one, but it is necessary for you to have this information and know it. So I'm going to go ahead and cover it. Okay, so what I have here is a similar scene to what we had in the previous video, only this is not a cached particle system. This is actually simulating. So if I select it and I go over here to the MCP and click on selection, you see that this does have an ice tree. Okay, so that's the first important thing to note. So I can't scrub backwards with this simulation. All right, so let's see how we can cache this simulation using a special node in the ice tree. Let's open up the ice tree. Let me go ahead and maybe increase the size of that a little bit and zoom in here. Okay, there's a node that we can use to cache inside of the ice tree. If we go over here to the preset manager, make sure you switch from task over here to tool, and you notice you have all these different tools that you can use. Well, the tool we're interested in is located in data access, and it's the CashOnFile node. So let's drag and drop that here into our ice tree. And you notice the first thing is that unlike other nodes, this one creates two, a current frame node and then a CashOnFile node. The CashOnFile node is the main one that we are interested in. Basically, the way this works is like this. Let's open up the CashOnFile node here. And we don't get too many options, so sometimes that can be a good thing. And we get these three tabs. First tab is the main tab, and you can set here the template path to use to save out the cache data. So by default it's set to the project path, which is what I recommend, or you can set up a temporary path or one of those alternate paths that you chose in the simulation preferences in the previous video. Okay, then we can over here in this input box, we can type into this field a custom name that we want for these particles. So for example, let's say I want to call it I don't know, super particles for some weird reason. Okay, so now they're called super particles. So now the particles will have this name, super particles, added to the whole file name. Okay, then we have a file mode. By default it's set to do nothing, so nothing happens. But we can set it to save the ice cache to file, or we can tell it to read from a file in our project. So let's set it to save because there's nothing to read right now, so we're going to go ahead and we're going to save. And after we tell it to save, we also have to go ahead and plug in this node into our ice tree. So where should it go plugged in? Well, this node should go plugged in as the last item in the ice tree. So let's take its execution port and let's plug it into a brand new port on the ice tree and make sure that it's the last port in the ice tree, even after simulate particles. Okay, once we do that, it's pretty simple. Let's go over here to copy files just to go over these other tabs very quickly. What you can do is you can copy these the ice cache to another directory. So you can choose another template path, you can choose a second path, and so on and so forth. We can also go to general controls and we can choose the attributes that we want to save out. Now by default, ICE is going to go ahead and save out all the attributes that you need, so you really don't have to worry. However, if for whatever reason you wanted to add any extra attributes, all you have to do is type them in. So let's say if you created your own attribute, you would come in here and type in my custom stuff or whatever your attribute's called, and then you could separate with a comma and type in your other attributes, and ICE will go ahead and cache those other attributes for you. In this case, we don't have any extra attributes, so the default will work just fine. We can also mute this, which we don't want to do right now. And then we have a few other options here which we can use to blend multiple caches together. We can normalize the cache and we can overlay and append it. What that basically means is that we can create a cache for another particle simulation. So let's say we have two different types of simulations. Maybe one shoots straight up in the air, maybe the other one orbits around an object, and we want to blend the two. Well, we can make multiple CashOnFile nodes and then just plug them in the order that we want them to play here with the ice tree. And you can go ahead and use these blending controls to go ahead and blend those together. But I don't recommend doing it through here. I strongly recommend doing it through the animation mixer as we saw in the previous video. Okay, that gives you a lot more power and control over this. Okay, so let's go back over here. We have it set to save file, so that's what it's going to do. Okay, so let's close that PPG. Let's go back to the first frame of the simulation, and let's go ahead and hit the end key on the keyboard to go to the last frame of the simulation. So it goes ahead and it calculates from 0 all the way to 1000. And really no point in sitting here and watching this, so I'll just pause the video and skip ahead. Okay, so it finished saving to disk. Okay, so let's open up the CashOnFile node again, and you can see it's set to save file. Just to see that it did save, let's hit 5 on the keyboard to open up a file browser, and you should be in the project directory. If you're not, go ahead and get to it. And then down under the simulation folder, under scene root, inside of point cloud, you should see this file called point cloud underscore super particles. There it is, and it's saved from frame 1 to 999. So let's close that. Now let's switch it to read from file. So let's select read from file here, and now what it's going to do, it's going to read super particles from the project path directory. Then since it's already saved, it's already there and ready for it. Now, to prove that it is going to read from those particles, let's do something here. The simulate particles node, as you've probably already seen after watching this tutorial so far, we need it to be able to simulate particles in our scene. Normally what happens if we disconnect that, the particles won't emit. So let's also disconnect the CashOnFile node, and let me show you what I'm talking about. I'll just collapse that to get it out of the way. Let's go to the first frame, let's hit play to simulate, and this is what you should get. The reason this is happening is because there's no particle simulation node plugged into the ice tree. So the particles are created, but they're not actually being simulated or anything like that. So when we plug in the CashOnFile node in here, just plug it back into the ice tree. Now what you'll notice is that if we play this, the simulation plays. That's because it's taking all the data from the cache file that we recorded, and it's playing it using this CashOnFile node right here. So it's a pretty useful way of caching your simulation, as well as reading it back. And like I said, it's very flexible. You can create 3 or 4 of these CashOnFile nodes, all of them containing different ice caches. Just rename them. Maybe one of them will can be named swirly effect, or whatever it is you want to name it. Another one could be called explosion or something like that. And then you can take all these CashOnFile nodes and you can load up all those different types of simulations and stack them on top of each other in different ports. And you can create some brand new custom simulations using that method. Okay, so it's very flexible and it's pretty powerful. Okay, so that's going to do it for this video. As a recommendation, when using the when working with cache files in the ice tree, don't really use it for your final caching. I strongly recommend using the animation mixer and using the animation tools here for plotting and writing geometry cache. I prefer that over using the ice tree CashOnFile node. Okay, but you can use whichever method works for you. So that's going to do it for this video. In the next video, we're going to look at one more method of how to cache using a different technique inside of XSI.